Scene script. Have you ever wondered why dx is not a fraction? It's a question that can leave many scratching their heads, especially when you first encounter it. To start, dx is a mathematical symbol that signifies the derivative of a function y with respect to x. Now, what does that mean? Essentially, it's a way to measure how the value of y changes as x changes. It may be tempting to see dx as a fraction. After all, it does appear like one. And there are even cases where we can add, subtract, multiply, and divide it by other expressions. However, it's crucial to remember that dx is not a fraction in the traditional sense. It's a mathematical object with its own unique properties and behavior. One key difference between dx and a fraction is that dx is defined as a limit. It's not a solid, specific value, but a value that we approach as we edge towards a certain limit. This aspect can make dx tricky to work with directly, so often we use other notations like yx to represent it. Despite these complexities, dx proves to be a powerful tool in mathematics and physics. It's instrumental in understanding how functions behave and how we can solve problems using them. Now let's delve into why dx is not a fraction. First off, we can take the derivative of a function even if the function is not defined at all points. For instance, the derivative of sin x is cos x, even though sin x isn't defined at x equals 0. If dx were a fraction, this wouldn't be possible. Secondly, we can find the derivative of a function even if the function isn't continuous. An example is the derivative of e circumflex x, which is e circumflex x, even though e circumflex x isn't continuous at x equals 0. Again, this wouldn't be possible if dx were a fraction. Lastly, the derivative of a function could be a complex number, even if the function is purely real. For example, the derivative of the square root of x squared plus 1 is 1/2 times the square root of x squared plus 1. Such a scenario wouldn't be possible if dx were a fraction. So, while dx may behave like a fraction and even look like one, it's not. It's a unique mathematical object with its own set of rules and properties. In the fascinating world of mathematics, dx is a powerful tool that helps us understand and solve complex problems.